Hello and welcome to another video. Today we have a very basic board on our bench again. B450 Pro Max AM4 board. This is like one of the most budget B450s that you can get, but it's still a decent board, can be used. And basically all AM4 boards have gone up in value a lot since the release of the X3D chips, and especially the 5700 X3D and the 5600 X3D. Not to mention the 5800 X3D, obviously. So, let's together find out what's wrong with this board. This board, I had a quick look at it, and it looks to be in fine condition, like nothing special. Haven't seen anything obvious at first glance. So we're instantly going to go over to putting a processor into here and getting a readout from the power supply what the passive power consumption is. So we have a 2200G in here. Let's get our power consumption onto here. So let's now turn on the power supply. 100 milliamps. That is very little. Okay, that might be that one of the standby rails is actually not running. But that also might just be the case for this board because there's barely anything on here. So let's get a DDR tester into here. Get some DDR4 also into here. And because this is a MSI board, this should have a TPM header exactly in the bottom left right there, where we can attach the postcard to get some postcodes from right there also. And I will be attaching a power button and a speaker also. So let's see now if we have a reaction to the power button. We have a reaction. Is there any postcodes going? There is postcodes going. 2.2 amps. We don't have postcodes out of the TPM, but it shouldn't matter really, because we got postcodes here, but the board seemed to have turned off by itself. Let's see, 360 milliamps. That is a weird state. 350 milliamps is like not being on, but not really being off as well. Let's see, does it react to the power button? It does not. Let's get another button into here to have the reset line. So we now have a reset line. Let's push the reset button. And let's see. Nothing also. Okay, let's cycle the board ourselves. Okay. Let's try this again. Have a look. 2.2. There's postcodes running on the DDR tester, and now it's off again. So 2.2 amps, and then it's off. Then it's not totally off, but it's like 350 milliamps. That is like almost being turned off. Let's try to reset the BIOS on this. Let's get the BIOS battery out of here, and let's hit the clear CMOS header on the bottom here. So the BIOS should be reset. Let's see if that made any difference. So again, 2 amps, 2.1. Is it going to, yeah, 350 milliamps again. Very weird behavior. Seems like it's a shut off of some sort, but I really couldn't tell why. Let's see if it does anything different with a different processor. So let's get a 2600 into here. If it still wants to shut off like it does. So turning it on. And basically the same behavior. Okay, let's swap RAM around, that we get the stick of RAM in the other channel. We might be even be able to better see what is happening with the postcode. So let me show you that once more. So we turn on and power button. Some postcodes running. And 350 milliamps, and that's it. Okay, let's see if our DDR voltages are all running. Or let's first see how this board behaves with no RAM. If it's just going to complain about missing RAM. Yeah, instantly complaining about missing RAM. Interesting. Let's get the DDR voltage tester into here. and see if our voltages are all present. So turning it on, complaining about RAM. VTT is missing. Is that so? So it seems like VTT isn't there. Okay, let's see if on the other slot VTT will also be missing. So turning on. And here VTT, oh, it's low. VTT is in general, this is very weird. Like the voltages in this slot are very weird. So vCore is definitely running. I feel the heat of the CPU. Let's have a look at the VTT area. The VTT should be somewhere in this area at the top right. Let's have a look now. Let's go under the microscope. So let's look at from the top right. So let's see if there's anything weird to be spotted here. But not much on here. Really almost nothing here. This might be the VTT. This is probably the VPP here somewhere. Yeah, this is probably around here for the VPP. So really almost nothing to be seen. Let's check that with our multimeter. So let's see now together. We're going to go over some of the RAM voltages. So let's see. We're going to be turning the board on. Oh yeah, I don't have. Yeah, right. Turning the board on. Let's see now. There is 5 volts there. Let's see, probably around here should be 1.2 volts. Yeah, 1.2 volts. VDDQ is present. Let's see, this should be VPP, I think. 2.5 volts, that is present. This is, I think, SPD. Yeah, 3.3 volts, which is present. Oh, you probably couldn't see that. Let's do that once more. So, what I'm probing, because I just looked at it myself. So, what I'm probing is this MOSFET and the output of this MOSFET, which is 1.2 volts. Then there's this inductor right here. This is the 5-volt dual, I think. 5 volts. Then next I would be probing there's a poly switch, like a fuse right down here, which is SPD most of the time, which is 3.3 volts. Then right here there's another small inductor, which would be VPP, which is 2.5 volts. That's probably 0.9 volts VDDP. No, this is 1.8 volts CPU. Then this is VDDP right here. And is this not present? Let's see. 12 volts, okay, but this should be, I think, VDDP right here. Interesting. Is the 1.8 volts on the BIOS chip present somewhere? Let's have a look. Yeah, 1.8 volts on the BIOS chip is present. So weird behavior now is that we do not have the VDDP, I think, which is this coil right here. So the VDDP is for, as far as I know, for the logic of the processor. So, oh, the processor very, very hot. I forgot that the vCore was running and I have no cooler on here. Let's put the cooler on here again. So let's see if the VDDP is present in standby, because it should be as far as I know. Do not see anything. What is on here? Is there 0.9 volts there? Also no. 1.8 is present. Let's try that again. So nothing. Let's try to put some RAM in here again and see how this board then behaves. Let's see. Let's turn it on. Now there's the very little power consumption that we had before, which is very weird. Let's turn it off. And let's cycle this board. turn it on, 2 amps, but we do not get this voltage whatsoever. And now it all has died down again. Let's see, are my RAM voltages still all present? Yeah, all of the RAM voltages are still there. We will have to find out where VTT goes to. So where 0.65 volts is, because that was kind of iffy. So let's get into board view and see where we can find VPP for the DDR. For that we need this, what you can see right here. This is MS77C52. This is the model number that we need to search for MSI board views and version 1.2. So let's have a look at that. So let's see, in the board view right now, let's search for VTT DDR. Let's see, it is supposed to be present from this controller, the RT8231. Yeah, from this controller there should be VTT DDR coming out. So let's see, is there a... No, it just directly connects. Okay, so it's a direct output. So let's go onto here, this area, and check if VTT is present. So this is our controller in question. Let's turn the power on. Let's turn on the board and let's see right there. We have 0.6. So that is present. So we don't have a problem with our DDR voltages as far as it seems. So we will have to take a look at the VPP, I think it is, that is missing. I just want to check once more in the different slot if we have the same behavior. Okay, let's go into the board view once more and check what this coil is that we had no voltage on. So the coil that we have no voltage on is this one. And it is CPU VDD, like I thought. Let's see. This is the 1.84 volt that we saw. This is also 1.8. And is there any like standby Vddp or something? Let me see here. No, I don't think so. I think this is the only. So this is the controller NB503GQ. Don't know that controller. It takes 12 watts as an input. CPU VDP 3.3 volts. It's just 3.3 volts being put into here. On 100k ohm resistor. Oh, this is from the power good signal. Okay, let's check what else it has. A lot of ground. We have the switch. This is the output. BST, this is the bootstrapping with the capacitor. CLM, this might be a control circuit. The power good, the feedback, the mode selection, and the enable signal coming into here. We will have to check that enable signal, and let's also check if the 12 volts come into here, but I think I've checked that 12 volts. And let's check that enable signal also, if that is present. So let's see now. This is 12 volts, yep, and on this diode here, there should be the enable signal. And we do not have that. So this enable signal right here is missing, and if I saw it correctly, the enable signal is coming from this AND gate, not AND gate. This is a dual MOSFET. I'm pretty sure where that is coming from. Let's check the resistance of the VDDP. It's probably going to be low because there's a CPU in here. Let's check it. Oh no, it isn't that low. So in kilo ohms, we don't have any reading as far as it seems. Yeah, this has high ohms on VDDP. Okay, so we will have to check why that VDDP enable signal is missing and where it's coming from. So let's have a look at that. So let's have a look now. I didn't look at this yet. This is the controller, the NB503GQ. Let's see. It takes V in. It takes 12 volts. Okay. That is present. We've seen that. It has the CPU VDDP enabled. That is what we were missing. So we will have to look at that. An internal 3.3 volt input. So this is the power good signal. This, why does it say it in input? This goes out. Okay, CLM, this just a resistor to ground. Mode, these two are both not selected. This is just ground. This is the feedback loop for its output. That's the bootstrapping, and we also have the Vddp switch, so the actual output itself. So let's search from this CPU Vddp enable comes from this down here, as you can see. We have CPU Vddp enable. So this is a double N-channel MOSFET. So what we have Vddp select and CPU Vddp enable. So let's have a closer look here. I want to explain this. So this is a MOSFET. This is just a switch. If there's voltage on G2, the source and drain is going to be connected to each other. Let's just break it down like that. So what we want is that there's voltage on CPU Vddp enable. So if type 0 CPU select will be high, we have a connection between D2 and S2. And this S2 is also connected here, which is Vddp select. So that means if this is selected right here, if we want this selection here, is the source of the other MOSFET. So we have another MOSFET, and if type 1 CPU select is high, this is coming from the CPU as far as I know itself, then this is going to be pulled to ground, which is the S1 here. So that means this gets a continuous path here. So we probably don't want this to happen. Let's see. What you can see here is the different CPU generations. So I think this is Raven or something called, and Matisse there's also, but I'm not too sure which one is which. And this tells you if this or this is going to be high or not. For example, for the SR generation, this and this should be high, which means the Vddp enable should be pulled low. But let's see where also CPU Vddp enable is, because there's probably somewhere a pull-up resistor also. So let's see. Can we find it anywhere else? Yeah, this is what I expected. But this is kind of weird. This is the diode that we saw. APU AM4R1 and the voltage divider from 12 volts Vddp. Okay, and what else do we have? This is just the enable once more. Okay, let's have a look at the board view then to also understand this. So now in our board view, the enable signal that we have seen, has one capacitor connected to it. We have this diode that we have seen. There's two N-channel MOSFETs. Oh yeah. Oh, this is a little bit different from... This seems to be different from what we had as the actual, how is it called? The PDF that we had. Because there's two directly connected to the CPU enable. So Q89 and Q92. Let's see once more into the schematic. So we only saw Q92, but there's one more. So yeah, there's one more that the PDF didn't show me before. So let's have a look at what this is. So we have CPU 1.8 enabled. This is present as far as I know, because the 1.8 is there. This is 5 VSB that connects to this gate and then pulls the CPU Vddp enabled low. Interesting. And does it also DDR power good? Oh, yeah, I see it now. This has a bigger chain. So we will have to start from a lower chain right here. You can see when the DDR gives out a power good signal, it will turn on this gate, which means this drain 1 is with source 2 connected. With the drain 1 is connected to source 1, which means it pulls it low to ground. This also is connected S2 here, to D2. As soon as sleep state 3 is being put out by the processor, this will now connect 5 VSB through this 47k ohm resistor to ground, because sleep state 3 is present, which means it's being pulled to ground, and also this is being pulled to ground right here because the data power grid is present, which then means that this gate here is not enabled anymore, which means CPU Vddp enable is not being pulled low anymore, just like CPU 1.8 volts enable isn't being pulled low anymore. So this is a chain of voltages where you check if either the voltages or some specific signals are present in order to enable or disable other voltages. This is the chain of power up sequence that we have. So we will still have to find out why our CPU Vddp enable now is low. So let's now check a voltage, which is this on this resistor right here. We should get 12 volts when we turn on. So let's see right here. We should get 12 volts. We have 12 volts. On the other side, we have nothing. So that probably means it's being actively pulled to ground then, because this is present, but this is not. So let's see if this is shorted. If it is, that means, yeah, we have 5 ohms. That means one of the dual NMOSes is being shorted to ground. So let's see. It's probably that top one. So currently it's a little bit confusing. I have to work myself into this a little bit. There's a table for when Vddp is being selected or enabled, which depends on the generation of CPU. My problem is I don't recognize all of these. This is Bristol Ridge, obviously. If we look at this, there's the CPUs. Where's Bristol Ridge? Shazam, where's Bristol Ridge? There's, as far as I know, there's Summit Ridge. Let me search for that. So let's see. Now we can see it. We have Bristol Ridge APUs, A series Athlon, which is this one. Then we have not estimated. This is probably for the later ones. Then we have SR, which is Summit Ridge. Then we have Raven and ZP. What is ZP? Raven Ridge, I know. But what is the other one? ZP. Raven Ridge. Matisse, Picasso, Renard, Vermeer. So really don't know what the other one is supposed to be. But as far as I know, these CPU type select should change if these are high or low. And I've now tried with different CPUs and I don't get any change in these. Whether these type selects are high or low. And they are supposed to be defined by core type, which is the similar table. And this core type is what enables or disables a signal for the core type CPU select. So you have the core type, which is coming out of the CPU, and it's pulling this base either high or low in order for the 5 VSB going to type 0 select. So pulling another gate high or low. And if we search for core type 0, if we go here, core type 0, this is connected to 1.8 volts to a signal which goes into here and also to the ZIF socket. So looking here, we have this 4.7k ohm resistor which goes to the base, which we saw, and we saw this 443 ohm resistor from 1.8, and this end here is connected to the CPU. So if we type this in, we get This is the CPU, this is the ZIF socket. On the right, you can see the ZIF socket. And this comes out of the core type 1 or core type 0. So the CPU is responsible for pulling this high or low. And so far, currently, I'm not getting any change. No matter what CPU I put in, I don't get a change in type 1 CPU or type 0 CPU. So this might be related to the BIOS not properly working. So I want to flash the BIOS and see if that will help in order for us to get these type selections right for the CPU. So Vddp will be enabled. So let me try that. So I will be using this TPM, this SPI header right here to connect to the BIOS chip and then flash this BIOS that is on here. So I can do it in circuit. And for doing it in circuit, you want to detach everything that is on here. So taking the CPU out, taking the RAM out, and all of the other stuff that is connected to there. So let me do that. So let us try the 2200G in here now. I've now flashed the BIOS on this. So hopefully Vddp won't be a problem anymore. If it still is, I will have to take a closer look when Vddp is supposed to be present and when not. So let's see now, 2200G. 2 amps. And do we go any further in our... No, we don't. We go back to 0.4 volts. Why though? Because the weird thing is, as soon as we don't put RAM into here, everything will just stay on. That is so weird. So I will be taking a look at the board closer to see if there's any knocked off or broken components here. Because this behavior right now is very weird. And I will also have a closer look at Vddp, try to understand, okay, now Vddp is present. Never mind. Okay, now Vddp is definitely present. So that works now. But if I put in RAM, it disappears, right? Because when there's RAM in here, let's see now. We don't have Vddp. And if I turn it, no, we have, yeah, okay. So we do now have Vddp. Interesting, okay. So that isn't a problem anymore. Vddp is now present, but there's still something wrong. Why this is shutting off? So let me have a look under the microscope and see if I can find any knocked off components. And would you look at that? There are 2 broken resistors near the PWM controller. How does that cause the board to turn off like it did before? That is so weird. Let's check what these resistors are for. And why would it turn off with those 2 missing? So let's have a look. It is this one. Yeah, this one is missing. vCore comparison. So I would guess that this might be something for like a feedback loop or something like that. Yeah, this is for feedback looping. Yeah, you can see vCore feedback that is connected to these resistors. So this is a protective shutdown because it cannot properly see that. But this is a capacitor that is knocked off here. A capacitor missing on the feedback. Okay, what is the other one? Which is this one. This line is called vCore IMON. Let's see, this is connected to this. And these signals are all not properly labeled. Yeah, none of these is actually vCore NTCP on this side. Negative temperature coefficient. But that's negative temperature coefficient. So this is a resistor that changes the resistance value based on heat. for measuring temperature. And this might be a thermal shutdown then, if this is actually that. And there's a vref also coming from here. Okay, let's see if I can find the data sheet of this, and we can see what pin 18 is supposed to be from the RT8894. So let's see. This is the PWM controller, and pin 18 is vCore IMON. Let's see where that goes. So this is for the vref circuit. As you can see, that is the signal that we saw, and this is connected to vref. So the reference voltage isn't there. That is one of the pins, okay? And the other one is vCore comp. And there, the missing capacitor, let's see, is the VC24. Let's search for that. VC24. There's some changelog. Yeah, this is this one right here. So this capacitor is on the comparison line VDD-CR CPU sense. This is for some sensing line where that is connected to. And let's see, where does this come from? Okay, I cannot tell where this is coming from, because a differential pair that is also coming out of the CPU or what? This is kind of weird. Let me see in the board view if I can get any more information out of this. So this is connected to also pin 15. Oh, and 15 is the vCore feedback. Okay. So it's kind of hard to tell why this isn't, like, what exactly it is not doing. But it seems like for the vref something is missing, and for the temperature also. Or for some comparison. So let's see. We need a capacitor. A 47 picofarad, if I'm not mistaken. So this one says C47P50-0402. So I think this is supposed to be 47 picofarad. And we're also missing this resistor right here, which is 130 ohms. Okay, that might be a bit more difficult to salvage. But let me have a look at my donor boards. So, I found a donor board, and I thought I might use the opportunity to test out this. You might have seen this from FNIRSI. This is a test tweezers for resistors, capacitors, and I think even inductors. So it comes in a very nice carrying case with replacement tips, as you can see there, these shiny ones, that screw onto the end here. Comes in this nice box here. Let's see, what does it have? It shows kilo ohms, yeah, resistor, test range, test voltage, frequency, battery level, measurement parameters, data hold units, auxiliary measurement parameters. Okay, it comes with the battery, obviously. Charges at 1 amp with 5 volts, has a small display. LCR-ST1, it's called. So it's a LCR meter. Testing capacitance, inductance, and resistance. Yeah. And this is supposed to be a very easy way to test that. My multimeter can test capacitance and resistance, obviously, but it cannot test inductance. So this would be a great addition in order to check inductance, which I also don't have an LCR meter for. So this could be a great addition. And let's now see if we can measure that resistor that I need to desolder from this board, which is, if it is 130 ohms, if I caught the right one. So let's go over this board. This is a B350 that probably carries very similar components, and let me see which resistor we need. So the resistor in question is supposed to be this one right here. Let me probe it. and see what this can say. 130 ohms it tells me. That is very good. So you cannot see that obviously. Let me change to the overhead view. Let me now see if I can probe it and also show you that. 130 ohms. It is not in focus, but you should be able to see that. Pretty much exactly 130 ohms. That worked better than I expected, to be honest. That is very cool. So we found our resistor. Let's desolder that resistor, put it onto our board. I only have that one, so I need to be really careful. And we will be using this again when we search for the capacitor. Probably also be taking from here. So it works really easily. That is cool to just be able to quickly do that. For resistors, obviously, it's not that useful because most multimeters do a good job. But especially on capacitors and inductors, this will be great. Like, this would be a great addition to my bench. So let's now be very careful. I have the resistor here, and this is the old resistor that is broken. I have only this single one to replace for, because I don't think any other of my other donor boards carry a 130 ohm resistor. So let's be careful with this one, that we can put it onto here properly. So I even took out my good tweezers to do that. So let's turn it over. Let's now tack on one of its sides. Like this. Taking the other side on, and now I'll be using hot air because now it cannot fly away anymore. So now using hot air and getting it into place just like that. So now it is in place. Now the 130 ohm resistor, which was the worst part of it, is done. Let me now go onto the other board and see if we can if I can find that capacitor also. So this board uses the exact same controller, but it fits a different capacitor in its place. This is a 68 picofarad right there. And I want to try the LCR meter on this and see if what it says. So let me get this flipped so I can probe it easily. And I want to know what the LCR meter says to this capacitor. So I want to check this capacitor. I had to unsolder one of these sides because checking capacitors in circuit isn't really indicative of anything. So one side is unsoldered, and now we can see 72 picofarads, which is pretty spot on. This is supposed to be a 60 picofarad, and capacitors have a pretty huge diversion of how their tolerances is. So 72 for 61 is totally fine. So it isn't really what the board had supplied previously, but this one uses the same controller and uses that capacitor. So let's just transfer this capacitor onto the other board, and I think we will be fine. So let's now get the solder points cleaned up here. And you can see the capacitor laying right here. So let's see, this is its top side. So let's tack on one side at least. Tack on the other side. This should be enough already, but I always like, after having done that, I always like to reflow them once more just to be sure. There you can see, it's now reflowed. And yeah, let's just clean the board up a little bit and then try again if this board now works. So I'm now very hopeful that this board will now work after all we've been through, and that was the reason for our shutdown. So let's see now. Let's hit our power button and see. So, power button, I don't have a speaker. Let's see now. Let's just see. I have a post screen connected. I was that confident. And there was 3 amps, no shutting down. It's still running. That is a very good sign. 2 amps. Let's see. 3 amps, 4 amps shutting down by itself, cycling. That is very good to see. We should get a post screen every second now. And there's the post screen. Let's see. Let's make it a little bit smaller. It reset by itself again. Let's see. And there's the BIOS screen. Thank God. There it is. That is what I wanted to see. Now the board is working. That is very great. So, quick recap. I don't know whether the VPP had an actual problem or not. I was going back and forth over the enable signals that I showed you before on those gates. And for whatever reason, it was never present. And after flashing the BIOS, it was present. So I think there was something wrong with the type select of the CPUs that were on this board. But I'm not too sure about that. Like, it just happened to not be a problem anymore, and it was after the BIOS flash. So I think that has helped with enabling Vddp properly after that, because I've measured this 2 or 3 times, just like the enable signal. It was always low, and now it seemed to have worked after flashing the BIOS. And then we still had the problem of the board shutting down, probably either to the VREF not being there or for some temperature control for the PWM controller, because of those knocked off components, that one resistor and that capacitor. And now it seems that we have everything fixed on this board, and we are able to use these tweezers. I gotta say, they're a very interesting concept, these tweezers. They can be helpful. I don't think they're really helpful for resistive measurements, except if you want to do it quickly. But if you have a bench multimeter or just a multimeter, resistance is not interesting. But being able to measure capacitance and inductance also is very great. Now I can show you. This has L for inductance, D for diodes, all in auto modus, resistance, and capacitance mode. So I think this can really be useful, especially because I did not have a way to measure inductance, and now I do have a way to measure inductance. Because my multimeter, also I've tried using the capacitance meter on my multimeter, but it really wasn't working too well. So I will also be able to now measure capacitance with this. But for capacitors and often also inductors, you have to be able to at least desolder one of these sides, because checking them in circuit just won't give you a proper reading. But doing it out of circuit, just desoldering one side, will make you able to use this. So if you repair more like switch mode power supplies or something like that, this can be very useful then. I just want to quickly check how this does on an electrolytic capacitor. So let's see, this is 826.3 volts. So I think, what is that? 820, it's not microfarads, is it? Let's see, capacitance. So, yeah, it's microfarads. So this is an 820 microfarad capacitor, and it's showing, man, it's so hard to capture this display. This display looks really good in person, but capturing it is awful. 940 microfarads. So that worked pretty good, and it measures the RS, the resistance of it, which is 19 mega ohms. So that is fine. It doesn't measure ESR as far as it seems, but the capacitance is really great to see, and it does that quite well and fast. So if you were in the business of checking, of repairing switch mode power supplies, this would be a lot better. But keep in mind, there's no ESR reading on this. So for quick testing, this is not bad, especially if you have a very basic multimeter. This can really be helpful. For me, it's a little bit hard to use on 0402 components. So I wouldn't recommend it if you're just checking 0402 components, because you can do it, I've done it, but it's hard to do so. I will only be using this for inductors when I need to measure inductors on boards, because the other, maybe even capacitors, some on the board, but for the other functions, for diodes and resistors, I will be using multimeter, but for capacitance and inductance, this can be useful. So I will be giving it quite a little bit more testing, and yeah, you will probably see this in my videos in the future, here and there. But yeah, decide for yourself if this is necessary for you or if you will have any use out of that. But I can say that it does work and it does what it needs to do. So thank you very much, Fnise, for also sponsoring this repair with this tool. Thank you very much for watching. I hope you learned something. All of my tools are linked in the video description. This was Mainboard Medic. Thank you very much and goodbye.